Okay, so we're going to take a look at security policies, and so as I said earlier, the fundamental building blocks are, of our firewall is zones and policies. This is the fundamentals. We will add other things onto that as we go on and look at other things that we can do, but these are the absolute fundamentals of building a firewall. So let's take a look at these policies now. So we're going to just do a review of this. We did look at it last week. So we're going to look at the functionality of policies and look at these things called ALG, which is a application layer gateway. We'll just take a look at what they do. Look at the components of a policy, how do we build this policy. We'll then look at how to monitor and verify policies, and I'm going to look at the basic elements of a policy. After we've gone through that, I'm going to then give you, show you some actual policies configured on a firewall. I'll look at some different configurations of different policies and just talk about what these policies are doing. So let's look at the overview of a policy. So what is a policy? So essentially, the device, our SRX device, our firewall, is going to be saying, what should I do if a packet comes in and matches a particular criteria? So what we already discovered here is that we have some criteria. So we've got this set of rules that tells the device what to do with transit traffic between zones and also within a zone. So here we're looking at the policy and the services ALG parts of the module of the firewall. So the packet comes in. The first thing we have to look at in making this decision is, does a security policy match the traffic? If it does, then we apply the policy. If it doesn't, we apply the default policy, or the device applies the default policy. Now, I guess one question we might answer right up front is, what is the default policy? And the default policy is deny everything. Alright, so basically, if you don't have a policy that says this is allowed, then it's denied. Basically how it works. So, let's take a look at the host inbound traffic. So the packet comes in. Is the packet destined to the incoming interface? Yes or no? So why would a packet be destined for the incoming interface? What does that even mean? Destined for the incoming interface.
To the specific interface?
Yeah. That means that the destination address on the packet is the same address as the interface. In other words, you're connecting to it, you're establishing maybe an SSH or a telnet or a HTTP connection to the device itself. Okay? So if the connection is to the device itself, so that's you managing the device, then the answer will be yes. If the answer is yes, then the question is that particular service or protocol allowed into that interface? So that's the host inbound traffic configuration thing on the zone. It gets evaluated there. If it's no, well then it must be transit traffic, right? It must be coming in on the interface and it's going somewhere else. It's transiting from one interface to another. So, does a security policy match the traffic? No, or yes. Now, if no, then the default policy applies. And this is important. If you go and say, okay, I've got this zone, I'm going to create another network segment within my zone, and you go ahead and you create another VLAN, and then you are going to then put devices on that particular VLAN and so on. So you configure your VLAN, you configure your devices, and away you go. And suddenly you find that for some reason or other, nothing can connect to your new VLAN. Well, the first thing you've got to think about is, how do I put my VLAN interface into a zone? Okay, oh yes, I'm going to do that. So you add the VLAN to the zone. And then the next thing you've got to think about is, how do I configure a policy within my zone that says traffic is allowed? between these two network segments inside my zone. Okay, so if you haven't done both of those things, then that traffic is going to go nowhere. You will not get any connection. So you have to put a policy in place. I'll give you an example of that later on. So then we apply the policies. Does the policy permit the traffic? Yes or no? And then there we go. So the policy does control what gets between the zones. Yeah.
Which one is the default policy? To drop everything?
Say what?
Which one is the default policy?
Oh, the default policy is no policy. If you don't have a policy,
Is to drop it
then everything gets dropped, yeah. If you don't have a policy, denial is the policy. Okay, so system default policy is denial of traffic to the device. You can change the default policy to the middle traffic, but you wouldn't, right? You wouldn't. That's the whole point of a firewall, is that you want to deny all traffic. You want to say what's allowed. And that's the point of the firewall. You want to say what's allowed. Factory default template security policies. So on our branch device, which is what we're using, you can go in and load factory default, as you will discover last term. And when you do that, it does in fact create some zones and some policies. And we do create, as we discovered, a untrust zone and a trust zone. And the policy is that everything is allowed from the trust zone to the untrust zone, but nothing is allowed from the untrust zone back to the trust zone. That's factory default. When you get a branch device out of the box, unpack it into green USRX, that's what's on it. Okay? That's what's on it. Okay. Will it work like that? What do you think? That will work? Do I have some devices in the trust zone? Am I going to get an internet connection? If I have my internet connection in my untrust zone, and I have my devices in the trust zone, will I get an internet connection? What do you think?
Communication is bidirectional.
Pardon?
What do you mean?
What I'm saying is just to say I've got some devices set up in the trust zone, and I've got my internet connection in the untrust zone. Will these devices be able to access the internet?
Yeah. No?
Well, it's a question. It could be yes, it could be no.
No. Packets come back. No.
Is it yes or is it no? That's what I want
So
to ask.
the default behavior is when the outbound traffic is permitted, and the coming back is going to be denied.
Yeah, so this is outbound permit. So from trust to untrust permit, from untrust to trust deny.
Yeah, but the coming packet is the information that you already request.
Yes.
It's not something that is asking to you.
Yes.
Your system. This is the reason why it's going to be allowed.
So you're saying yes, internet works,
Yeah.
and you're right. It does work. It does work. Exactly. Because it's a stateful firewall. Right? So what that means is if the policy says the traffic is allowed, so if the connection is initiated from the trust zone and that connection is permitted by policy, then the return traffic for that connection is also permitted. Okay, that's how a stateful firewall works. A stateful firewall is aware of traffic as a session, in that it has traffic going out and it has return traffic coming back. So you could say, as we do, nothing is allowed from the internet into the inside world, and yet every connection that's established from within that trust zone, all the return traffic is allowed back. Okay, but you try and get a connection from out here, you try and initiate a connection from the untrust zone into the trust zone, no, you're not going to allow it. Okay, you won't allow anything to be initiated from out here to get inside that trust zone. But anything initiated from here, return traffic will be allowed back, because that's how a stateful firewall works. We actually covered that last week in bit of detail. Okay. Alrighty, so security policies, let's look at this example here. We've got this zone called a private zone, we've got another zone over here called external zone, and we have a public zone. 3 zones. Host B initiates SSH to host D. Let's take a look at this. So where's host B sitting there in our private zone? SSH to host D over there in the external zone. So the flow is from B to D. Security policy permits the flow. Therefore, the flow triggers a reverse flow creation, and both flows result in a formed session. Okay, that's the function of the stateful firewall. It creates a reverse flow. So it says policy allowed out, then I'm going to allow return traffic back. That is called a session. Outgoing flow, incoming flow. That creates a session. Okay, return traffic. It also receives permission. Okay. Right, does that make sense? Okay. The return flow is allowed. That creates a session. That's how a stateful firewall works. Okay, policy ordering is important. They are processed from top down or in order. Therefore, you don't have something that says allow everything before you have something that says don't allow this stuff. Okay, you have more specific ones earlier on. You can change the order using the insert. Command. Change the order around. Okay, some of the other things we can use on policy, which are really useful. Of course, we can delete them, but what I found particularly useful is the deactivate and activate criteria, because you can create a policy, you can test it out, and you can say, actually, I don't want that to be enforced right now, and you can deactivate the policy, and you might want to make it active at a later date. So you've created it, yes, it works, let's deactivate it for now, because I won't activate it later. This activate, deactivate works really good when we're going to look at this thing called a scheduler soon, and it works really well with the scheduler. We can insert, annotate, copy a policy, rename it, and do search and replace. That's kind of a really handy thing as well. The actual command for that is replace pattern. So if I want to replace something, let's just say I rename the zone, whatever reason. Okay, you could then go and search and replace the zone name through all the policies, for example. Let's look at these things called application layer gateways. They're software processes that manage protocols. Now, protocols, forgive me why we have these, but protocols usually use dynamic client and server ports for different parts of the communication. So here's the situation. We have our stateful firewall. You make a connection. The policy says yes, the connection is permitted. So the stateful firewall then creates a return flow for that connection. So we create a connection, say on port 21 FTP. The section says, okay, I'm going to allow return traffic from that same IP address on port 21. So return traffic is allowed. So port 21 is allowed out, port 21 is allowed back. There's my session, port 21. But what happens is, so with FTP, port 21 is the control channel for establishing the connection. The actual data comes back on port 20. So I haven't created a return flow for port 20. That's not allowed in unless I use what's called a application layer gateway. Now these application layer gateways are built into the firewall. They're there by default. Okay. What application layer gateways does is, oh, hang on, this is an FTP connection. I need to open up a return flow on port 20 as well, because this is FTP. And it does it automatically. Okay, so it opens up what is known as a pinhole. In other words, just a port, a pinhole says from this IP address on this port, this is allowed. It's called a pinhole. So here we have, this is FTP right here, so here we have going out, establishing on port 21. This is our session being established. It's called our control channel. But then what happens is, look at this. Suddenly we have got we have got traffic coming back on port 20. Suddenly we've got traffic back on port 20. Okay, now if we do not have our ALG running, this will not be allowed. But because our ALG has created what's called a pinhole, in other words, a return flow on port 20, the return flow comes back, hits the pinhole, it's allowed through. Okay, so that's what the ALG does. It opens up this thing called a pinhole when the return traffic is different on a different port to the initial outgoing traffic. And you get a few things like that. FTP one happens automatically. It just happens. It's built in. It just does it. You don't even know it's happening really. Just does it. You can go in and change these things around. There are quite a few of them in there. Different ALGs for different protocols. You can change them. You can create them. You can add new ones if you need to. We can view them and so on. This is just to let you know that they exist, and we can configure them. We can change them. You know, edit them if you need to. This is the DNS ALG. Disable it. Sometimes you may want to disable it. I've had a situation where I disable it for VoIP because they didn't work properly. So if you do disable it, you have to create a policy, a separate policy to allow that return traffic back in. This is FTP. Okay, so we can go and verify that the policy, or the applied policy, is using an ALG. If we do the show security policy detail, we'll take a look at that later on. We'll see that we do have some of those configured. Okay, now how do we build a policy? Let's get into this. How do we build a policy? Well, first of all, we have a context. It's from a zone to a zone. So a policy is always controlling traffic from a zone to a zone. Always from a zone to a zone. So we go under the Edit Security Policies hierarchy, and we will type in set from this zone to that zone. And then we will create our policy. We're going to give it a name, user-defined name. We will then have some matching criteria, which must include source address, destination address, and an application. 3 things must have in a policy. We then have an action, which can be permit, deny, reject. We can also log it, and we can also count it if you need to do those things. We can also, we use these policies to invoke other functionality, which we will talk about later on, such as IDP or UTM functionality. Okay, so we use a policy to invoke this functionality. So these are other things invoked within policy. Okay, let's have a look at the matching criteria. Source address, and a destination address and an application. Now, when we have a source address, we don't go and just type the IP address into the policy. What we do is we previously, before we go and create the policy, we create a thing called an address book. In the address book, we put a name of a thing and its IP address. Let's just say we want to create a policy to allow traffic into an FTP server inside our organization. So we go into our address book and we say FTP server, and we put the address 10.10.1.12, for example. That's our FTP server. Then in our policy, we'll go in and we'll say destination address. We don't type 10.10.4.12, we type FTP server. Because we predefined that in our address book as a thing that we're going to include in our policies. So, and the reason we do that is because if we ever change the address of our FTP server, we don't have to go and edit each and every policy that may refer to it. We simply edit our address book, and it's just in one place. So we get to control the addresses of things in our address book, and we can just reference the things themselves in the policy. That is a pretty standard sort of way of configuring these types of environments. even from different vendors, like if you have a 40 gig file, for example, this sort of thing, you will use a similar approach. Okay, applications. We can. There are a lot of system-defined applications already in there. We'll take a look at a list of those later on, or we can go and define our own. Quite often, though, the application that you want to permit or deny, depends what you're doing, will be system-defined. For example, FTP is system-defined, DNS is system-defined. There is a great long list of applications that are already defined in the operating system, and all you have to do is reference them here, and they'll be there. I have had situations where they weren't defined. I had to go and create my own one. I had to create a policy for Asterisk, Asterisk was it IX2 protocol. It wasn't in there. I had to define it, and then I can put it into a policy. It's fairly easy to do. Okay, so these are our address books here. So we would have an address name. It might be FTP server. It has an address slash whatever. We might have another thing there, which may be web server, and it's got an address. So these addresses go underneath a zone. So that the policy. So the way it works is if I am referencing a policy from a zone to a zone, from an address to an address, the from addresses are going to be in the from zone, and the source addresses are going to be in the from zone, and the destination addresses are going to be in the to zone. Okay, so we put our addresses source in the zone that we're having traffic from, and destination in the zone that the traffic is going to. So that's how we kind of organise our addresses, our address books into our zones. So if I'm allowing traffic from the internet to HTTP server, which in our case in this campus is in the zone called classrooms. So I'm going from untrust to classrooms, source anything, destination FTP server. So the FTP server address book is sitting in the classrooms zone, because that's the to of the policy, which is the destination, and then of course the protocol. So must have source address, must have destination address. We can go ahead and create IPv6 address book entries as well. This is really good as well. You can create a DNS name instead of an IPv4 address. So in your address book, you simply put a DNS name, and that is really useful. I had to use that in a situation where the address I wanted to allow, or the device, the idea of what the device I wanted to allow had a changing IP address. Okay, so there was a remote access requirement, but the person who had the requirement didn't have a static IP address. They had a dynamic IP address, so it changed all the time. And so after a while, I said, "Hang on, is there a better way of doing this?" Yes, let's just put the DNS name of the device. That way, no matter what the IP address was, as long as we could do a DNS lookup, which we could, we can allow that device in. Okay, so you can use a DNS name. Really useful when you don't have a static IP address associated with the entity that requires access, or the device that requires access. Okay, really useful. Okay, and of course, you would need to have your name server set up, which you would. You always do that anyway. Okay, you wouldn't have that done. Okay, this is the applications now, and examples may be GNOS. Let's just say I need to allow, I've got a VoIP server on premises. I need to allow SIP in. So and get phone calls. Of course, I would configure that as my application. Okay, so I would say I'm going to allow the policy would kind of go from zone internet to zone maybe VoIP. Source address would be the source address of my internet telephony service provider, so it would be their address, the IP address of their server. Destination address would be the address of my VoIP server. So I would have in my sort of internet zone address book, I might have the name of my internet telephony service provider, whatever their name was, and their address. And then in my zone, my internal zone where my VoIP server was located, maybe I call it my VoIP zone, whatever, I would have a name which might say VoIP server and its address. So I would then reference those two addresses in my source and in my destination. Source address, my internet telephony service provider. Destination, VoIP server. Application, SIP. Action would then be commit. So we'll get it and look at that. I might need some other protocols there as well for VoIP. In fact, I would, wouldn't I? I would also need my real-time transport protocol coming for VoIP as well, so that I could get audio or video for that matter. What's coming through. All right. So what we've got is we can go ahead and create custom applications if we need to. Usually you won't, but you may need to. And it's not that difficult to do. Okay, we can look at the predefined ones, doing the show groups Junos defaults applications, and we'll get a great long list of applications that are already in the system. This is an example of the first one here, which is FTP. There it is, using protocol TCP coming in on port 21. It's a great long list of them. What is to go ahead and create a new one? Just give it the protocol, give it the port number. Not that difficult. Okay. Can alter pre-configured applications as well. There's also things called application sets, not really mentioned here, but we'll look at those later on. What they are, they're a group of applications, and it's just useful to use them. For example, if I've set up Exchange, Microsoft Exchange server, and I need to allow a whole bunch of protocols in to my Exchange server, Juniper has already created an application set which groups all the protocols you need for Exchange server to work. And you just go and reference that application set and say commit, and automatically done all that. So it just saves you, oh, I need this one, oh, and I need that one, oh, and I need that one. Okay, they're all pre-configured as a set. You can create additional application sets. It just means that in the security policy, you get to reference one thing instead of many things. Just sort of makes it easier. Okay, this is verifying the security. So show security flow session. And we can see that we've got this is us actually reconfiguring an application in that session. Creating policy match entries. So here we are. We have got our matching criteria: source address, destination address, and application. You're going to need those three things, and then you can have another policy with its matching criteria as well. And they are executed in order. What are the actions that we get to put? Commit, deny, reject, and also log, and also count. As I mentioned earlier, we can also invoke other security mechanisms like IDP or UDP in our policies. Other things we can do is we can put in place firewall authentication, where you have to actually be authenticated So I have to verify who is the person who is accessing or is creating that particular connection between the zones. That's not a possibility. Okay. And we can set that up using a some kind of device that authenticates a user. So it may require, it may be that only certain users are allowed to create a connection from that zone to that zone. And in which case we would have an authentication mechanism, a database that provided that authentication for us. There could be different devices that may do that. Let's turn that noise off. Okay. All right, global policies are a policy where you don't have to say from a zone to a zone. This may be a policy that applies across multiple zones. So where there may be a number of different zones involved in a particular policy, we can just say that traffic is allowed from this entity or from this source address to that destination address. We can create a policy that just may encompass multiple zones. And it's just used to simplify a situation where maybe you would have to create 3 policies, or we can simply do it with just the one. It's kind of a global policy kicks in. An example of a global policy. Where we're saying, this is just going back and recapping our summary of our security policies. That's not a global policy. That's a regular security policy. So we have got from a zone to a zone. We've got source address, destination address, then the action. So we matching and then the action. You're going to have to put all those components to create a policy. Context, matching, action. Then we can verify the operation of a policy. So we'll get into how we do that. We can go and look at our syslog, which is our standard log. We can go and look in there. We'll see. We can go in there and we can look at what's happening, if there's any errors, etc., with our policies, with our logging. File messages, look at our logs. Just looking at the sample log there. We can set up logging on a policy. This is a policy that we're setting logging on. So policy 812, then log. We used to count in a security policy, so we can count how many sessions are initiated. We can log sessions that are initiated. Looking at show commands, show security policies. We can go through and look at the detail on the security policies if you need to. See exactly what's in there. I actually do show you some examples of this as well. Now, last thing we'll look at here is scheduling. Scheduling is a really useful tool. Scheduling is where you want to say, okay, I want to put a policy in place, but I don't want the policy to be active all the time. I want that policy maybe to be active after hours, so that I want the policy to be in place maybe from 5 o'clock or maybe 6 o'clock until in the afternoon, or maybe 8 o'clock the next morning. So maybe it's an after hours policy or whatever. So we can have this scheduler where we can set up a policy. We can set up a scheduler, and then we apply the scheduler to the policy. I'll give you an example of that. Once we have a look at some policies, when the scheduler is active, so in other words, whenever the scheduler says the policy is now on, during these times, the policy becomes active. At other times, which are outside the times in your scheduler, the policy is then deactivated. So I could set up a scheduler and say, I want this policy to be active from Monday to Friday, or whatever, every day of the week, from say 6 p.m. to 8 a.m. the next morning. That's when it's active. policy goes active at those times, and then outside of those times, the policy is deactivated. It can be an automatic thing. So, basically, there's a couple of different ways we can do it. We can set up a what's called a slot schedule, to start time, date, and stop time and date. So it's just during a period of time. Or we can say this is a daily scheduler, start time, stop time, and then we can have the day of the week, or we can exclude certain times as well. So a bit of flexibility around how we do it. I'll give you an example of one. We can take a look at that. So this is an example of a scheduler. And then we apply the scheduler to the policy, which is just applied there in the policy itself, so it comes right after the action. Sorry, yeah, right after the action, the policy, the schedule. We can use this as a policy rematch statement. What this means is if I go in and reconfigure my policy, then what will happen is it'll drop the session and create a whole new session. If I don't put the rematch, I can reschedule the I can reconfigure the policy, but it won't automatically pull the session down. We'll leave the session up until it automatically times out, and then the next time it's created, it will be created a new policy. So that's all that rematch does. It's basically how it affects existing sessions. All right. Well, let's take a look at a case study where we want to achieve a particular result. So our objectives are, so we've got these two zones, we've got HR and we've got public, and our objectives are to allow PCA and PCB to FTP to server C using our custom application set, and we want to deny other users into the HR zone from using FTP services into the 1.1.7.24 network. Log and count these violations. Okay, so PCA, there it is up there in the HR zone. And PCB in there in the HR zone. We want them to connect to server C over here in the public zone. We want to customize the application set. Do that. All other users in the HR zone, which we don't see any, but we do see it. We've got these other networks down there. All other users in the HR zone are denied from using FTP services. So let's take a look at that there. So this is our security zones. We're going to set up our address book because we need to set up our address book first before we can create our policies. Because we're going to have to reference the devices in our address book in our policy. So step one, we've got to go and create our address book. We've got to list all the entities that we're going to be including in our policy in our address book. That's the first thing we do. So we've got PCA and its address, PCB and its address. We have got all 10-1 PCs, and we've got a /16 on that. So that encompasses that whole block of addresses in that particular entity. We've got an address set. These are really useful address sets because you can put lots of addresses that you predefine can then be subsequently included in the address set, and then in your policy you simply reference the address set name, which in this case is HRPCs, instead of having to reference each and every address individually, or each and every entity individually. The beauty of that is you might decide later on, actually I have some more PCs in HR that I'd like to be able to FTP across into that server. All you do, you don't have to change your policy, you just add them into your address set and they have access automatically. So here we have our address book there set up, and there's our address book in our public zone because we've got some stuff over here we want to reference in our policy. We've got server C, we've got something called address all 1170. That's got a /24 on that. And we've got an address set called service C, which I think is a bit redundant, quite frankly, because you don't really need to create an address set and you've only got one address in your set. Okay, you could have actually stuck with, you could have quite happily not had that address set. You could have quite happily just referenced service C in the policy. Okay, so here's our applications. We actually created some custom applications here as well, and we've also got including our custom application in what's called an application set. And now here's our policy. So we are matching the source, which is HR PCs, which was the two PCs, which are PCA and PCB, because that's our address set there. Destination address is public, which is, we go back and look at that. It's an address set, which is address public. And we've got our service C in there, so that's actually service C. And applications, HR public applications, which is an application set, so it includes FTP, IKE, and Telnet. Then permit, and we want to log those sessions and count them. So that is the policy from HR zone to zone public. And now we've got other policy, which matches everything else. And the application is FTP, and we're denying it, and we're logging in, counting that as well. Okay, so that's how we set it up. So step one, we set up our address books. Of course, the very first thing is we set up our zone. Hopefully we've got that set up already. Then we go ahead and set up our address books. We need to, if we want to use custom applications, we need to go and create those custom applications. If we don't, we can skip that step altogether. And then we go ahead and build our policy. Okay, so step one, set up your address book. Step two, do I need any custom applications? If I do, let's set those up. Step three, build your policy. You're referencing your source, your destination, and your applications in your policy, referencing your actions, and then commit, and we're done. Now we can view and verify the policy. So we can do a show security policy, policy name, HR to public detail. We can just check that policy. But we'll see everything that's in it. We've got our from zone to zone, source addresses, destination address. Let's look at that source address there. I'm wondering where the other PC is. There should be two in there. I reckon we should be seeing, we're using HR PCs, we should be seeing PCA and PCB in there. Just looking at that. Yeah, I reckon they might have stuffed that up in the slide actually. It should be two PCs there. And so C is applications. We are in fact using our application layer gateway for FTP in there, which is kicked in, and there's the traffic. Okay, it's a log. Okay, so what I want to do, I'm going to show you some examples of some policies. I'll just go through and talk about them. So we've had a look at what policies, how they work. Look at this thing called the application layer gateway. Look at components of a policy, which was the source, destination, application, match, and action. We looked at verifying policies, and how to configure a basic policy. So your approach to the policy is, okay, what am I going to reference in my policy? Well, let's go and build my address book, so I've got those things already sorted. do I need to do anything with a custom application, or I'm just going to use a standard application? I might want to go and look through what applications are available in Juniper in the operating system to begin with. So is it in there? Well, that's all right to do. Is it? Why have they got AX in here? No, they don't. Okay, I need to build that. So I'm going to build that custom application. Now we've got all that ready to go. Let's build our policy and reference all those things in our policy and commit it and good to go. Okay, so basic components of a policy are
source address, destination address.
Yep. So we do. We have the context of the policy from a zone to a zone.
Yeah.
We have our matching, source, destination, application. We have our action. Commit, deny, log, count, reject as well. Yep. What is the default action? Deny everything. Yeah. General policy, deny everything. What does the schedule do?
Programming the times of when the policy is gonna
Be
action.
active. Yeah. So it's when the policy will be active. A reorder policy is using, what's the command?
Insert.
Insert command. Insert command. Yeah, okay. How are we going for time? We have got some time. Okay. A little bit of time before lunch. What I'm going to do is let's just go in and we'll take a look at some policies here. Let's dive out of there. Let's dive into here again. And let's open that. So what we can do is we can do a show security policies. If I just do that, I'm going to see absolutely every policy that's configured on the device. So that may not be overly interesting. So what am I going to do is go from a zone, let's do untrust to zone classrooms. Let's look at those policies. So there's quite a few policies set up there. Let's take a look at some of these. This is a policy which is called FTP. It's currently enabled. Source address was any. Destination address was FTP server. And the applications that were allowed into it are predefined. These are predefined Juniper applications, Junos FTP and Junos HTTP. And the action was permit. Okay, so we're permitting access to our FTP server with that policy. Okay, here's another policy. Policy is access server. This one's enabled as well. Source address any, destination address is the access server. Application is telnet and permit. Okay. So you can telnet into the application server, sorry, the access server, because this policy allows telnet access to that server. Policy home, state enabled, source address home, destination address any, applications any. Okay, that's interesting. There's another policy there. Here's another policy, pulse secure, that's enabled as well, source address any, destination pulse secure, and the applications HTTPS, HTTP, permit and log. So we're just going through and looking at the policies. Here is another policy, Pulse VPN Students, which is enabled, source address Pulse VPN Students, destination any actions, application any actions permit. Okay, so these are the policies that are allowed from the outside world into the classroom zone. Okay, let's take a look at some of those default policies. show. What do we want to see here? I want to see. Let's take a look. I want to show. Let me just have a bit of a look here at what I want to see. Okay, let's take a look at this. Show groups, students, default applications. Show groups, not liking it. I want to let's take a look at this. Junos defaults and applications. Okay, so this is what's pre-configured already. So here we have FTP, TFTP. There's going to be quite a lot of these. We've got a real-time streaming protocol, some NetBIOS stuff there, SMB, server message block protocol, SSH is predefined, Telnet is predefined, SMTP, which is our mail server protocol, predefined, Tactus server, DHCP, it's client and server protocols, predefined, bootPC, bootPS, HTTP, as you expect, HTTPS, POP3. So these are all predefined protocols. NTP, predefined. IMAP, predefined. BGPs, LDAPs. So there's lots and lots of predefined protocols that are already there that we can reference in security policies. IKE. Lots and lots of them, so up to 25% so far. Right? So there's quite a lot in there. Lots and lots of policies, and as we, applications that we can reference in security policies. So if we get right down to the bottom, we will actually see some application sets. Here we go. There's an application set. You can see some of those. There's one for CIFS, which is the Windows networking file protocol, Common Internet File System, CIFS. And that's an application set as to what protocols I will need to allow that protocol to work. So application sets. Okay, so there's quite a few predefined applications and application sets, but you can create custom ones if you need to. Okay, let's. What I want to do is just for a few minutes, I'm just going to look at a configuration which is kind of interesting, because this is a router that I actually configured up at home, at my house. It's a SRX. I just happen to have one laying around, so put it in. Now, let's just take a bit of a look at it, because it's kind of interesting, just to give you an idea of what's happening and how it works. Obviously, we've got some time zones. Got a name for it. We've got a time zone set up. There we've got our DNS servers set up. Got some usernames, well, one anyway, mine, set up. Different services that we are going to be using. We've got DHCP running. We have got a gateway that we're putting out. This is part of our DHCP. There's a default gateway. There's an address pool. We've got some static bindings in there that was useful that I wanted to put in to my DHCP. And what else have we got down here? Net time. Yeah, so interfaces, interface configurations. So we've got GE 0001, 2, 3, 4, 5, 6. They're all set up as switching interfaces. So they're just operating as layer 2 switches. 7 is when my internet comes in. It's got PPP over Ethernet on there. Actually, I don't think I'm using that at all. I think that may be unused at current 7. In actual fact, the internet comes in on this here. This particular device has got a DSL module in it. So it actually has got a DSL interface in the device itself. This is it here, AT100. Encapsulation is Ethernet over ATM, which is my layer 2 sort of base level encapsulation. On unit 0, I've got an encapsulation of PPP over Ethernet over ATM. It's kind of what you have to do on that type of interface. This is my logical interface where I've got PPP configured, and this is the PPPoE protocol set up. Underlying interface is my actual interface where my cable attaches to, so my cable actually plugs into there. RJ11 socket plugs into there, so that's where my ISP comes in. Other interfaces that are of interest, this one here is ST0, is used for route-based VPNs. We will be doing VPNs later on in this term, and we'll look at how to configure up a route-based VPN using that particular interface. We've got some VLAN interfaces as well, just one actually, VLAN 0. We've got some static routes, we've got some trace options set up on my PPPoE because I want to find out when my internet connection drops out. Now this next section is going to be very, very big. This is our IDP section. We'll get into IDP later on. I'm just going to go through that. What I want to get to is the actual policies, which down here. Zones, okay. Here's some policies. Let's go look at these policies. Get that one there. UTM flow. This was setting up my maximum segment size because we are using PPPoE. Screen options. We will get into screen options later on in this term and what they do. In fact, I think that's coming up next. Here's our policies. So, from zone, trust, to zone, untrust. This is a policy which was called Wizard 101. I was pretty interested in blocking access to this particular gaming site for some reason. Okay, I just had this, I don't know, urge at this particular moment that I needed to block access to this gaming site. The policy is currently inactive, but the source address was any and the destination address was Wizard 101. Now this is actually an address set. I want to show you the benefit of using an address set. Okay, application was any and then deny. There's another policy which is called League of Legends. So there's just a couple of policies that were created where we've got source address any, destination address, League of Legends. Now these are coming from the trust zone, which is inside, to the untrust zone, to the Ethernet. So these policies apply to traffic coming from internal to external. So they were denying access from inside devices to devices on the internet. Okay, so this was the purpose of that particular policy. These policies are currently inactive. Here's another policy, which is DNS allow. So this policy allows DNS. Source address any, destination address any, application is Junos. DNS UDP, then permit, and this is another inactive policy, which is an interesting policy because what it does is this is remember from the internal zone to the external zone. What it does is it matches any destination address. Source address is boys. Okay, now that's an address set there. Okay, that's an address set. We'll take a look at who's in that address set shortly, but it's whoever's in that address set. Destination any, which is anything on the internet, and the application was UDP and SIP and deny. Okay, so what this policy does, it denies any UDP and SIP traffic from inside to outside. Okay, that's what it does. And so you might think of, why am I doing that? Okay, well, when you're designing a policy, what you really have to be very clear about is what is the objective of my policy. Okay, now one of the objectives that I had when I was setting up this particular policy is I wanted to block games of any kind. Right? I wanted to block any kind of computer game, any kind of games where so I just want to basically stop games from working. That was kind of the objective of my policy. So what I first of all did, my first approach was, well, let's take a look at some specific games that I wanted to block and let's set them up. Let's just see how that works. Well, that kind of worked well, but the issue is it only worked on specific games. And then I decided, well, what I really want to do, and in fact, the games that I first blocked was one called League of Legends and one called Wizard 101. Then I thought, well, actually, what I really want to do is I want to block all games. So let's have a think about how games work. And let's have a think about something that may be common to all games. Well, as it turns out, all games rely on UDP. Why do they rely on UDP? Well, because they're very video intensive, very graphics intensive. So they're going to be streaming lots and lots of UDP traffic. Okay. The other thing that games use quite commonly to set up their sessions is they will use the SIP protocol to set up their sessions. The other thing that commonly happens with gaming is that you will be playing a game, but you'll also be in a chat session with the people you're playing games with. Okay, so the SIP stuff, which is kind of the VoIP setup, and the gaming is something that kind of goes together. So it was kind of convenient to block all UDP traffic and all SIP traffic. And in doing those two things, which are quite simple things, the overall effect is that no games work. Okay, no games work. So if I want to say I don't want any gaming going on, that policy effectively does that quite well, very simply. Now, the other thing I did was I said, well, maybe I'll allow gaming sometimes. So what I did is I put a scheduler on the policy. Okay, so there's been a few policies over the time here. This is a block all, which basically blocks absolutely all traffic from inside to outside. So I want to say there's going to be no internet connectivity whatsoever. Then I can make that policy active, apply a scheduler to it, and say between this time and that time there'll be no internet. My goodness, no internet. How can life continue? Well, that can happen. Okay, so we can actually block internet for certain addresses for certain times. So for other addresses that are not included in the source address boys will have internet access, but any addresses that are included in this source address boys will have no internet access while this scheduler is in effect. Okay, that's nasty, isn't it? That's nasty. Okay, but I'm just showing you the things that you can do, okay, with policies and with schedulers. And if you kind of configure things, you can say, well, what do I want to achieve? I want this policy to do a particular thing. And if you sort of think about what you want to do, you can kind of make it happen. So that's just that's that there. This is another. This is the permit. This is my permit all here. So this is my then permit stuff, and I'm invoking IDP here as well, which is my intruder detection and prevention. I'm also invoking UTM, which stands for Unified Threat Management, and I have a policy for that, which I'm invoking in this particular policy right here. This is my permit all policy. I have some zones, have some address books in there, have an address set called boys, which includes all those particular addresses. So that's when I put boys in a policy, it includes all of these. That's nasty, isn't it? Host inbound traffic, so I'm allowing everything in, protocols, I'm allowing everything in, that's fine. Interface in that particular zone is VLAN 0. This is an address book. Now, this is really, I just left this here as an example of where an address set is really, really useful. We have these addresses for League of Legends. Now, what I discovered is League of Legends, the game, actually has lots and lots of servers. And if you wanted to block it, you had to block all the servers that were associated with it. And as it turned out, there are 75 servers. And so, they are the IP addresses of all 75 servers. Okay, now I created an address set called League of Legends, which includes all 75 servers. So in my policy, if I go back and look at the policy that I used that in, all I had to do in my policy, this is the beauty of an address set, destination address, League of Legends. Okay, so that address set includes all 75 addresses, right, of those servers. So that's the beauty of an address set. The beauty of an address set is if I didn't have that, I would have had to list lots and lots and lots of max 75 different things in this policy. But by using an address set like that, if I discover, oh, hang on, there's another server that they've created, I just go and add that into my address book, all right, and problem solved. Okay, so you can just add addresses into an address set, commit changes, and problem solved. So that's just showing you the advantage of an address set there. All those addresses are included. And this is also an address set. It's called boys, so it includes certain addresses there that I was interested in blocking there. Okay. What I will say, just another point on this, that if you are trying to block certain specific devices in a policy, you will define those devices in an address book. But if you're using DHCP to provide the IP addresses to those devices, be aware that that may change. So what you really need to do when you are configuring DHCP, I'll just flick back up to this and show you that. What you may want to do is configure some static bindings in your DHCP so that those particular devices, and here's an example of a MAC address of a device. Okay, that particular device will always get the same IP address. So that means that my security policy will always be effective because the device that I'm referencing will always have, essentially it's got a static IP without having a static IP. So if that device is removed from this network and put into another network, it'll get a dynamically allocated IP address, no problem. But as soon as it goes back into this network where this policy will apply, it will always get the same IP address. Okay, so the policy will always work. Does that make sense? So if you are going to have dynamically assigned IP addresses, make sure you go into your DHCP pool and configure static bindings for the devices that you want to include in your policy.
You can put more than one IP. The
Hey, what's that?
You can put more than one IP.
Did I do what?
More than one IP.
Yes, I've actually, there's a few devices that I didn't want their addresses changing, so I had static bindings for all of them. This one was called Jonathan's PC. This one was called Jonathan's laptop. This one was called Will PC. This one was called... So basically there was a few devices which you give them names, right? So you can identify what they are. And then you create static bindings for them. Forgot what this one was. So the result is, I mean, you don't want to give the devices themselves static IP addresses, right? Because you want those devices to be able to receive dynamic IP addresses because they're mobile devices. They'll be taken into other situations and other networks. So you don't want the devices themselves to have static IP addresses, but you want them to always have the same IP address when they're in this network. Okay? And that's achieved through static bindings in your DHCP. All right. Okay, so that was a bit of an interesting look at security policies. One quick look before we vanish for lunch is this is a scheduler where we've got Monday start time. It starts at 1 minute past midnight. It finishes at 3 p.m. in the afternoon. And this one starts at 10 o'clock in the evening and finishes at 1 minute before midnight. So what that means is that during these times the policy is active. Okay, so what it effectively means is the policy is inactive between 3 p.m. and 10 p.m.
And you have a different schedules for different days.
So what I've got is, yeah, I can have different days. I can say different times for different days as well. I might say, well, on these days I'm going to have this time, but on another day I'm going to have this time. So I can have different times for different. Friday, or Friday. See, they get to play more games on Fridays. Yeah, generous of me. No school the next day. So yeah, so this is, you know, okay. Was just an example of what you can do with policies and schedulers and so on. Okay, so there's a few things going on there. So you've got to think about a few things, right, to build your policies and achieve your goals. But basically, all these things tie in together. And away we go. All right, guys, let's take a lunch break.